Hello there, pre-calc. This is Mrs. Granny coming to you from my living room. Today is the first day of online learning, and I hope we are ready. I just want you to know I miss seeing all of you. I miss having our class together. I've had so much fun with you, and hopefully what we can do here is continue our learning. My job is to prepare you for calculus, and I'm going to do the best job I can from here while you are there, and we're going to stay safe, and we're going to proceed with our curriculum. So, I know you have those packets, and we left off just about ready to start section 6.7 and 6.8. And what we're doing in this section is we're going to be graphing the reciprocal functions that we're working with. So the reciprocal of sine is cosecant. So we're going to graph the cosecant function. So you should already know all the values of sine. And what I've done here, and I'd like you to do, is graph very lightly a sine curve. Now for the values of cosecant, remember that's the reciprocal of sine. So any number over 0 would be undefined. So all of the reciprocals of zeros are undefined. The reciprocal of 1/2 is 2. So I'm going to go ahead and fill in with all of these 2's and negative 2's. The reciprocal of root 2 over 2 is 1.4. So I'm going to go ahead and fill in all of these root 2 over 2's to be positive or negative 1.4. The reciprocal of root 3 over 2 is about 1.15, so I'm just going to put 1.2 to make it easier. Okay, and negative 1.2, negative 1.2, and the reciprocal of 1 is 1, reciprocal of negative 1 is negative 1. So now what we're going to do is we're going to graph these values. Okay, and what you'll see is they basically repeat themselves, positive and negative. So at pi over 6, we have a value of 2. At pi over 4, we have a value of 1.4. At pi over 3, we have a value of 1.2. And then at pi over 2, we have 1. And then it goes right back up again. There are no values. It is undefined at 0 and pi. And what happens here is those are our asymptotes. And our function will look like this. For the second part of this, here we have 7 pi over 6 has a height of negative 2. 5 pi over 4 has a height of negative 1.4. 4 pi over 3 has a height of 1.2. And 3 pi over 2 has a height of negative 1. And then that pattern goes back up. And again, we have an asymptote at 2 pi. So this is what it looks like. Okay, and this would repeat itself. So over here we would have the same, looks like an upside down parabola, doesn't it? Okay, and then over here this would repeat, because this is also cyclical, just like the sine curve. So that's what our y equals cosecant of x graph will look like. And that's basically what I need you to know, is to be able to identify that this is the graph of y equals cosecant. So now what I want you to do is I want you to pause this video, and I want you to go ahead and see if you remember all of these values off the top of your head, which you should. Sketch a little graph of y equals cosine of x. Find the reciprocal values for secant, and then graph that and see how that looks. When you're done with that, go ahead and turn this video on and see if you got it right. Okay, so how did you do? Hopefully you got these right. What you'll notice is these two graphs look a lot alike. The difference is that the asymptotes for sine are at the multiples of pi, so pi times any integer. And the asymptotes for cosine are at pi over 2 times any integer. Okay, so again, you're going to have to just know what these look like and be able to identify them. Okay? So we're going to turn to the next page, and what I'd like you to do is the same thing here. I want you to write the values of tangent, graph tangent right here, and then write the reciprocal values of tangent, so in other words, the cotangent, and go ahead and graph cotangent down here. Stop the video, then check back and see if you get the right values. Okay, so hopefully you did okay on this. If you wanted to, also remember you can always put this into your calculator. You would want to put it into radians, and you might want to change your domain and range just so you could see it. But this is what these graphs would look like. These are the values from tangent and cotangent. And what you'll notice is that the cycle just keeps repeating itself for tangent, and then for cotangent, it's shifted over and reflected, and you can see the differences there. So take a look at this chart. This explains it all. So the period for both of them is pi. The domain for both of them is all real numbers, except when you're dealing with the graph of tangent, x cannot be pi over 2 times any integer. For cotangent, x cannot be pi times n, where n is any integer. That's where you get your asymptotes. Okay, so that's what we're looking at here. For each of them, the range is negative infinity to infinity. Okay, you can see what our x-intercepts are. There are multiple x-intercepts, okay, wherever these graphs intersect the x-axis. The graph of tangent has a y-intercept at 0. The graph of cotangent does not have any y-intercept. And here are those asymptotes that we talked about. So that's it for today's lesson. Like I said, you really just need to acquaint yourselves with these graphs and be able to sort of pick them out of a lineup. In other words, if there was a matching section, I'd want you to know which one was which. Okay, we'll pick this up tomorrow. Have a great day, everybody.